Thanks very much, everybody. So my name is Benjamin Lucas. I'm the Managing Director of the Data-Driven Discovery Initiative here at the University of Nottingham, which you can check out our website now, which is 3di.ac.uk. 3DI is a portfolio initiative. We're grouping together all the wonderful things we do in all things data science, as part of this initiative, with a particular focus on economic and societal data science. So we're very much working at the government and commercial nexus. In particular, as part of this initiative, we're going to invest in themes such as fintech and law tech, computational econometrics, pedagogical innovation focused on data science. And we have two main flagship projects, one being decisionmakerpanel.ac.uk, and one being tracktheeconomy.ac.uk, which we're here to speak about today. I have with me John Gathergood, who is a professor of economics and our associate pro-vice chancellor in the Faculty of Social Sciences, who will be talking about the research backdrop and really the core part of the offering of our new institute. And also Fabian Gunziger, who is our lead developer and lead researcher on the project. Basically, how we're packaging Track the Economy is, again, as a not-for-profit institute based here in Nottingham. We intend to be a full-service one-stop shop for real-time economic tracking, with our core offering being the TE dashboard, which we're going to talk about today. The other thing I wanted to mention before we kick off is that we're obviously extremely grateful for the funding from BIES via UKRI for this project. And with that, I'll hand over to John, who will talk through some of our research.
Okay, many thanks. So I'm going to share my screen, and hopefully you can see a set of slides on COVID-19 recovery and beyond Track the Economy. So, as Ben has mentioned, this is a UKRI funded project. So many thanks to UKRI through the COVID-19 Rapid Response Grants. We've funded this work, and the work is both around collating real-time indicators, as we've heard quite a lot about already today. In our case, the real-time indicators that we're collating are principally from private sector sources, and then analyzing those and visualizing them in a way which is hopefully useful for policymakers and for a broader audience. And what we're particularly focused on is really trying to fulfill the need for real-time and geographically granular measurement of activity in the economy. And to do this, we're going to bring together relatively new microdata sources that exist in what we call real time, but as Luke has mentioned in the previous session, it's probably close to real time. So data that's available maybe with a lag of a few days or maybe up to a week, to give us a much faster set of indicators than we might have had previously. And then at a geographically granular level. So by geographically granular level here, most of the analysis that we're doing is getting down to local authority level or NUTS2 level. But because we're using individual level data, we do hope to be able to go more granular with some analyses in future. And then the project seeks to apply these new data sources to topical questions, and then, as I mentioned, generate a dashboard tool for policymakers. So there's three principal private sector data providers that we're working with. So first of all, Experian. So Experian was probably a household name now in the UK as a credit reference agency, and they have shared with us commercial and consumer credit file information that allows us to build views of firm financial distress, consumer and firm credit searches, consumer financial distress, and business creation at the unit level of the individual or the firm that can then be built up to these geographically granular views. Second, we work with a firm called Fable Data. Now, Fable is able to contribute transaction level credit card spending data provided by UK financial institutions. So we see a very rich flow of transactions with some geocodes attached to those so that we can understand where these transactions are taking place. And then HUC. So HUC is a company that's able to surface mobile phone location data for a very large sample of mobile phones. And this is an international operation as well. I should say that Fable also uses internationally sourced data. And so we can see these data from multiple nations, but we focus here again on the UK. And so this is data, this HUC data really is real-time data because HUC received data at 15-minute intervals. So one can get a very much real-time view of where mobile phones are moving around the UK. In our case, we're going to think of real-time as being a day or a few days lag in which we construct the indices. And as you would expect with mobile phone data, we have geomarkers, and then we can layer on top various other location-specific tags to the raw data. And so we've been using these data to deliver some insights on the emerging economic consequences of the pandemic. I'll talk briefly about a couple of pieces that we've done previously, and then show some new work that we're putting out this week. So for example, last summer, when local lockdowns were a thing in the UK, as we remember, we were able to compare the economic effects of local lockdowns as they translated to credit card spending in an area that was subject to a local lockdown compared with a nearby area that wasn't subject to a local lockdown. So on bottom of the screen here, bottom left, you'll see a time series plot comparing Liverpool and Manchester. And you can see the big decline in spending with the national lockdown, the recovery through the spring to summer of last year. And then we were particularly interested in what was happening when local lockdowns were imposed. And we found in that piece of work that consumer spending was remarkably resilient to local lockdowns, at least as measured in credit card spending. Later, we did some work looking at the effects of the pandemic on online versus offline spending, because that's again been a very big topic throughout this last year or so. And on the right-hand side, we have some plots where we were analyzing data at the NUTS2 level to understand the effects on online and offline sales through the period of 2020. But as we're emerging out of the COVID pandemic, as well as using these data to analyze COVID relevant issues, we can also use these data to analyze a broader other set of issues, including some of the issues around leveling up, which again has been mentioned today as an emerging topic of increasing interest. And so in some very recent work that we're doing at the moment, we're looking at the experience of local authorities as a unit of analysis over the long term and then over the COVID period, using the data that we have and that we can combine with some traditional data sources. So in particular, at the local authority level, we're looking at the long-term economic situation of local authorities through the lens of the index of multiple deprivation, which is a well-known data asset in the UK. And then for the same set of local authorities, we've created what we'll call an index of COVID impact, which is taking our measures from Experian, Fable, HUC, and then also integrating some local level data from the Bank of England Decision Maker Panel, which is also run out of the University of Nottingham, to generate an index of the impact of COVID on local authorities using a weighted average of these measures. So we can sense which local authorities across a number of measures have been hardest hit in terms of increased financial distress for consumers and firms, reduced spending, reduced mobility, and then worsened business expectations. And we're going to compare then the long-term situation of local authorities as measured in the index of multiple deprivation with this short-term experience of local authorities as measured by our index of COVID impact. Now, what I'm about to show you in the next couple of minutes is for England. We also have analyses for other nations and part of the United Kingdom, but we're going to focus here in particular on England. And here's a plot which forms the base of our analysis. So each dot on the plot is a local authority based on 311 areas in England. We don't look at some like the Isles of Scilly or the very centre of London, which have extremely small populations. So each dot is a local authority. And on the x-axis, we've ranked our local authorities by their position in the index of multiple deprivation. So the farthest left, the top ranked, is the most deprived local authority in the UK, and the furthest to the right is the least deprived. On the y-axis, we've done the same with our COVID index, ranking local authorities by the extent of a negative impact of COVID. So down at the bottom, the top ranked, if you like, number one local authority by COVID impact is the hardest hit by financial distress and reduced spending and reduced mobility and worse business expectations. Whereas at the top of the chart, we have the least hit. Now, what's notable is you can see that these local authorities are dispersed, really dispersed quite widely across this plot. If they were all lined up on a 45-degree line with a perfect correlation, that would tell us that the index of multiple deprivation just maps very nicely one-to-one onto the COVID experience. But it doesn't. Instead, we've got this big dispersion, and you can look at the four quadrants of the plot as representing four different types of experience. So in the bottom left quadrant, we have the most deprived local authorities, which have had the worst COVID experience. And so we just called out Great Yarmouth and Blackpool as two examples of local authorities, if you like, have the double hit of already being quite deprived and then having a negative experience. Top right is, of course, the opposite, the least deprived local authorities that have had the least worst, or maybe you'd even say the best COVID experience. And so here we have Rushcliffe, south of Nottingham, and South Cambridgeshire, already quite affluent and have maybe been hit less by COVID. And then in the other two quadrants, well, top left, we have deprived areas that haven't had such a bad COVID, if you like. And then bottom right, we have affluent areas that maybe have had a difficult COVID, ranking higher on our impact of COVID index. So you then might ask, well, given that these dots are spread across the screen, how might we understand or categorize the different types of local authorities that sit in different parts of the plot? One way to categorize local authorities, which is very much in vogue at the moment, is through their categorization for eligibility for levelling up fund support. So there's these three categories, with one being the local authorities identified as being at most need of levelling up fund support, the most eligible, and three being the least need. And so on this plot, we've just coloured the same dots for local authorities by their levelling up fund category. And what you can see from the plot is that the colours seem to move left to right in particular. So that tells us that the levelling up fund categories correlate quite highly with the index of multiple deprivation. And we see indeed that that is the case. But they don't seem to explain quite as well the COVID experience, in that you have dots going left to right by colour, but not really clearly going top to bottom by colour on this plot. So what might help us instead to understand the COVID experience alongside the underlying deprivation of particular areas of the UK? Well, to get a view on that, we've actually found the ONS supergroups to be quite a useful lens for understanding these dual impacts. So on this plot, we've got the same data points and the same X and Y axis, but now we've just broken out the local authorities into their ONS supergroup, which are ways to describe the demographic and the underlying economic situation of areas of the UK. For example, we have affluent England, or London cosmopolitan, or town and country living. And what's notable here is that if we focus on that bottom left quadrant, the local authorities that have the largest underlying deprivation and the largest negative COVID hit, they show up in certain ONS supergroups in particular. So we're probably familiar with the idea that ethnically diverse metropolitan living areas have been particularly hit by COVID, and also areas that show quite a high levels of long-term deprivation. And so perhaps unsurprisingly, this middle plot here with the blue dots is showing a lot of blue dots in the bottom left-hand quadrant. But then there's other areas, like areas of countryside living in particular. We've seen areas that are very dependent upon tourism, domestically be hit in particular ways, and that's very strong when it comes to the decision maker panel. Some areas of London, think about Newham, for example, as a dot there, which is nearly in the bottom left-hand corner, which has had a bad hit from COVID as well, being an area of earlier deprivation. Then there's other areas of the UK that just don't show up in the bottom left corner at all, maybe affluent England, or perhaps surprisingly, the services and industrial legacy parts of the UK. They're very much to the left. Many of those areas were areas of relatively high deprivation, being often clusters outside of major cities, like smallish towns on the edge of large cities, but they've actually not had as bad a COVID experience in general, because much of the economic activity that would have flowed to the center of the city through retail spending and mobility is actually staying in those towns on the fringes of cities that previously we thought of as losing out somewhat, but actually haven't done as badly during COVID. So you can see from these data that they give us a new way to understand the experience of different areas in the UK, and one which is really very relevant at the moment. So we'd say that these kind of data combined with existing data sources are able to give us a richer picture of the UK. Now, this piece of analysis is just one piece of analysis that we've done, and Fabian's going to quickly show us a dashboard that we've created that allows us to use, view, and cut the data in a number of different ways.
All right. Hello, everyone. I'm just going to assume that you can all see the dashboard and hear me, and otherwise just give me a shout. So as John mentioned, the idea, the goal of the dashboard is really to show a set of real-time indicators on different levels of economic granularity, of geographic granularity. And we can see here a view of the dashboard. It comes embedded in a website that gives you some additional information about the people behind the projects, the aim, our partners, and the dashboard works fine embedded inside that website. But we can also move to a full screen mode, which is what I'm going to do. It gives us a bit more real estate to work with. So as you can see here, the basic UK view of the dashboard gives you the set of indicators John has already briefly mentioned. And then up here, we have a set of tabs that gives you different levels of geographic granularity. The indicators currently are grouped into consumers, firms, health, and mobility, which is something that over time we hope to expand both with administrative data sets and hopefully also data sets from more private partners. And on the right, we have the main output, which is a time series plot, which is for all series except for the COVID indicators. It's indexed to January 2020, so as to give an easy impression of what happened since the beginning of the pandemic. So the general pattern will be that early in 2020, things are pretty stable and steady. And then sometime mid to late March, the pandemic hits and things start happening, and they usually start getting a bit rockier over here. And so we can look at a number of different indicators at the same time. We can have a look at travel, which roughly shows the pattern I suppose we would all imagine. We can look at COVID indicators, which we just pull in through the API of Public Health England, which is really very well done public API, because they're scaled differently. They're all expressed as a percentage of the underlying population. We show them on a separate scale here on the right. And you can see, so for the UK as a whole, it's been just north of 7% of the population has been reported to be infected by COVID. You can see up to 3 indicators at the same time. So if we go on a 4th one, it would just automatically deselect the previously 3rd one and swap those 2 out. If you're curious what average travel distance stands for, you can get more information on all the indicators here in the help menu. And then you can see that average travel distance is the median of individual maximum distances traveled away from home, which is a bit of a mouthful, but that's what this is. And so it's based on, as John has mentioned before, it's based on mobile device positioning data. This page also gives you a bit more information about the frequency of those data, how they're pre-processed, and all the data providers behind it. It also shows you that we plan to update the dashboard every Monday morning. And it gives you a bit more detail about what regions and local areas are based on. So the regions are based on NUTS 2 boundaries, local areas are based on local area district boundaries. So let's have a look at those regions. So the user interface is very similar, with the main difference being the interactive map in the middle here, which has, so it's interactive, and it's colored by the latest available value of the first selected indicator. So currently that's total consumption. It's the first and the only selected indicator. And the idea of the choropleth shading is really mainly to help you discover potentially interesting areas to look at, right? So you could see, well, up here, southern Scotland, that one's quite dark. So I might want to have a look at this one, or up down here, Essex, a little lighter. Might want to have a look at what's going on here. And just as before, we can view different indicators at the same time. So if you want to learn a bit more about what has happened in Essex, we can again select the same set of indicators that we had before. At the local area district level, things are very similar, with the main exception that the set of indicators is slightly smaller. And the difference is that here we don't show consumption subcategories, simply because at the moment, the sample sizes that these would be based on are often too small to construct reliable indicators. So that's something that currently we're working on together with Fable. We're quite hopeful that over the next few weeks, we'll be able to provide these indicators as well. The rest of the indicator set is exactly the same. And again, it works. It works in the same way as we just saw before. What we can also do with regions and with local areas is, instead of looking at a different set of indicators for one area, we can flip things around and say we want to look at one indicator, but see how it's developed in a set of areas. And so we can toggle that view up here. So if we switch to comparing multiple areas, we have a very similar view, but now the indicators become radio buttons. So we'll only be able to select one, but we can now select different areas. So if we maybe have a look at cumulative COVID cases, and we could then see that, well, up here in the north, as I suppose we all know, things are a bit darker and COVID cases tend to be a bit higher in certain areas. So we might want to have a look at this one. And then we might be curious too about, say, how things look in certain London borough, and we could either go find them down here, or if we have a particular one in mind, we can also just use the search menu up here and then select the area this way. And it will automatically be colored in on the map here because the colors are quite close. It's a bit hard to see. And then we could just flip around and maybe have a look at Barking after all. And this view, I think, is particularly nice if we want to just explore a series of different indicators in different areas, because also we always get the choropleth view in the map, so we can have a look at the mobility indicators. And
so sorry,
already,
Fabian, could you come to your conclusion, please? We need to get the next presenter.
Yeah, very sorry. So just was about to say that even the choropleth map might already give you quite interesting information, and then help guide you to areas that might be of particular interest to you. These are the basic features of the dashboard. So I'm not sure if we have a minute more for Ben Lucas to wrap things up, but that's it from my side.
So I think we need to, we've got some time for Q&A. Maybe Ben might want to reflect during that period, but I think we need to get on to Seb's presentation. So the next presentation 6, and we will do Q&A for both elements, is around tracking the COVID crisis with high resolution transaction data. This is, I think, really interesting, and we've had some experiments with this over the last 18 months. But basically, given that every time you transact digitally, it generates essentially data as a bright pipe product, can you use essentially billions of transactions from the credit and debit cards to work out what's going on in the economy? So, Sevi, over to you.
Hi. Hello, hi. Can you hear me?
Yes.
Can you see me and can you see the slides?
Yes and yes.
Perfect. Okay, so hi, thanks for having us here. This is what I'm going to present. I have the slides of the other one, but I'm going to present is the next paper to that one. So this is part of a large project that we have been working. So some British-based academics and with people of BBVA research. We are working in a long-run project with BBVA to try to, how will I say it? To try to make use of transaction data in a broad manner. So what we aim to do, our first, I was going to say our first long-run goal, but I don't know if that makes sense. It's to build national accounts, and to build national accounts in a broad sense. So in which the time span, it's arbitrary, can be last week, and in which the geographic area can be arbitrarily defined. And what we are trying to do first is to learn how to use transaction data for these things. So of course, consequences of this will tell us things about consumption during COVID and whatnot. So let me tell you what we are doing and how we are doing and what we are. So the summary of COVID and data as we see it is before COVID, there was a growing interest with people using relatively small data sets relating to financial transactions. Now, in COVID, then there was explosion of data and mostly payments data, mostly credit cards for tracking activity. And now there are, I think that our paper was the first doing this, the first one came out during COVID, but then there has been, I don't know, 5 million papers on this. I think that if you don't have a paper on this, nobody loves you or something. There are many papers using these kind of things right now. Now, as a consequence, there is many people around the world in many institutions trying to see what they can do with this data. And our project is we take, and I think this is accurate, a near complete record of financial transactions from BBVA, a very large bank, and ask whether it can be used to build, again, broadly understood national statistics. A little bit of why do we do this? The transaction data has this thing that it's everywhere and happens all the time. Each time that somebody buys or sells something, this is recorded. Even when the transaction is with cash, there is a record because you have taken the cash from a bank, and the seller is going to put the cash inside the bank. So the transactions can be followed, and essentially all legal economic activity in the Western world and even beyond, it's recorded, and from it, it's potentially usable and can shed light in not only on the state of the economy, but in the workings of the economy. So first of all, it's available in real time. So as everybody knows here, and you have all talked. Now, the second point is that the samples are huge. If in some places there is nationwide, right? It tends to be small nations, but In our case, it's a large bank. It's a bank that it depends how you measure the share is between 10 and 15% of the share of Spain, of a large economy, or relatively large economy. The collection of them, this is a thing that talking with for people from statistical office is a little bit of a dangerous word. The collection of the data is free in the sense that it's there. It's expensive in the sense that you need to build the machinery to make use of it. And this is by no means easy, and it's very costly. BBVA has spent lots of money into this, not because of us, they want to do it. And then once this is done, we need to learn how to do it and how to translate this data into usable things. Because the main challenge is that this data is accidental. The people didn't write the records to help science or help the government or help us understanding anything. They kept them because they had to, and they put it in the way that it was more useful for them at the time. And consequently, this data has many potential sources of biases and noise. And we need to clean them. And it's a complex task to clean it, and this is what we are trying to do. So let me tell you about the bank. The bank is Banco Bilbao, the official name is Banco Bilbao Vizcaya Argentaria. It's a Spanish multinational bank. It operates in many countries. The largest country of operation is Mexico, actually, where it has way more than a third of the market. Spain, which is its headquarters and its core, it has, as I said, it's more than 10%, 10–15% of the market. And in Turkey, it's a very large bank too, to get an idea. It's a large bank. It has the total amount of assets is huge. It's 727 billion euros. And we are working in partnership with BBVA Research, with their big data division, which are awesome guys, and we're working with them. Okay, so we have, from the bank, we have the complete record. So we have the transactions, and this, I'm going to divide it in two sorts, actually three sorts if you want. I'm going to talk mostly about one, credit card, but I want you to have in mind the whole picture. So there is credit card data. So each time that you buy with a card which is issued by BBVA, we know that you're buying. BBVA also sells, has a service for companies of using the point of sale machine. So each time that you buy, even with a card from another bank, via BBVA, we do know that you have bought. So this is a sort of data. The card data tends to be very well structured, and it's easy to deal with. And that's why I'm going to talk mostly about it today. But it's not the only source of data. There are two other sources of data which are much bigger in number of transactions. One is transfers made from a bank to another bank. So from a private company to another private company. This is when I don't know, Sony buys something from a provider. It pays cash. It pays with a transfer, and we can observe this transfer. And whenever it goes, we know the IBAN of both sides. Whenever the one of the sides it's a BBVA client, we know a lot about the site. We know essentially everything about them. What do they sell? How much do they sell? What are their business? Whatever. And the third source of information is transactions done from an individual in their account to either other individuals or to firms, or to himself in another account. This is movements within the bank account of the guy. One has to be careful because some of them will be debit card usage data that it's also in the card data separately, so you have to clean it and not count it twice, etc., etc. But this data is also valuable. This data is very important for many things. It's very important for measuring things like regular payments. If you pay energy bills, if you pay your rentals, if you pay the rent of your house, if you pay these things, you tend not to do it with a credit card. You tend to do it through this kind of mechanism. For things of consumption is important, but for other things of looking at investments and so also, but I'm not going to talk about that today. I'm going to talk mostly about consumption. Now, the raw spending data is biased and noisy in all these, and now from now on until further notice, I'm going to talk mostly about only about car data. So the raw spending data is biased and noisy, and but in spite of it, as people have seen before, it provides of a good coincident indicator of consumption. So we did see in the past that it's a very good coincident indicator of consumption, how it evolves. So this will be more or less the purple line is more like the raw data, but then you have to take decisions about how to filter certain things. And when you do it, and when you do it with care and love, you end up having something which is the blue line. Sorry, somebody came to my office. You are in the blue line, which and the green line it's the data from the Spanish Statistical Office, the equivalent to the ONS in Spain. And as you see, once you take care of things, it's more than the tracking. You get the level quite well. It's not. Doesn't only tell you how things move, it kind of tells you where you are. Now, a little bit about the car data. The number of transactions is very large. The number of transactions we use is all transactions from the second quarter of 2015 to the first quarter of 2021. So this is lots of data, lots of transactions. These are car transactions data that, as I said, are easier to use because you know that one person was buying and the other one was selling, and you know the person who was selling is a company, and you know that the person who was buying is a person, so it's a consumption item. So the number of distinctive customer IDs that we have is 7 million. Spain has 45 million inhabitants. The active customers, that there are several definitions. In this, the one that I'm using here, which is around 2 million, is at least one transaction per quarter in each quarter of the data. Now it's around 2 million. The number of transactions, now the definition of what is, the first thing that you have to think is what is an active customer for you, and it's not obvious because different people start using a bank, gets a card, then buys two things, then starts using some other bank, who knows. So oops, this is one of my co-authors in this paper telling me things about it. The red line here, it's these are the clients with at least a transaction in a quarter. And you see it's growing.
Sorry, Sevi, sorry, yes. You've got 2 minutes, I'm afraid, before we need to break for Q&A. So can
oh my goodness! I didn't know it was so. Okay. So the first point is we can track the data. The bank mimics Spanish society quite well, and we can track things, doing things carefully with other things. This is the evolution of payments between cash, online, offline over time. This little thing here is COVID. So in online, offline, it's true that COVID moved things a little bit, but you see the secular trends seems to be much more important also for cash. Finally, where I go, interesting, we can cross this data directly with income data from the guys. We see who gets wage and how much wage do they have, and then we can observe things like here we are, like this. This is spending growth and consumption growth of people. This is percentiles of income growth, and this means how is growth of income happening for the richest guy and for the poorest guy in the economy. Boom. This is the 2017, 2019. This is for the income growth, and this is for consumption growth. Which, by the way, it means that Spain was not getting more unequal in the years before COVID, at least, and their consumption growth was more or less flat. Everybody was eating more or less the same, more than the previous year in percentage. And this is the thing for income growth. What you see is during the pandemic, this is the difference between 2020 and 2019. You see during the pandemic, there was no growth. People didn't get more money. While in the previous years, there was growth. It was more or less homogeneous for all income groups. Then it happened, the pandemic. Now, in consumption growth, you can see that the rich guys decrease their consumption much more than the poor guys. And this was because they could not consume things that they like to consume, like going on holidays and things like this. And finally, consequently, they had a much bigger increase in their savings, in their private savings, which will have consequences. I'm sorry, I didn't realize the time. I thought that I was not aware of the time. So these are our conclusions.
Don't worry. I mean, it's a shame, but obviously the conclusions are up there, and we can follow up. But we've got a couple of minutes now just for Q&A, and I think there's an awful lot in those two sessions. So I'm really keen I do get to ask some questions. So the first one, perhaps the most relevant one here, is what are the biggest challenges of using real-time data? So maybe start with Sevi and then go to John.
I don't know real-time data in general. I don't know the other one. I have used Google data. I have used transaction data. With transaction data, the difficulty is the magnitude. There are too many things you have to clean away, and you have to make sure you don't sum things that you don't want to sum. Transaction data is brutal, and you have to clean a lot. To be careful with what you do. Eventually, we'll be able to. I think that we will be able to use real-time data out of it, but I think it's going to take a while in us learning to use it properly and to build consolidated numbers out of it.
Yeah, so size, as Sevi had said, absolutely. But I think also sampling, and this goes back maybe to the top of what Ian was talking about this morning. We have to be mindful that we come from a world in the national accounts where we're forever trying to draw representative samples and aggregate them to reflect some aggregation over the population. And in the real-time privately sourced data, more often than not, you get a particular sample, maybe from one market participant, from one geography, and you've got to do a lot of work. So one of the first things we did with the transaction data, for example, was just correlate it with Bank of England credit card spending data to try and see if we aggregate the two, do we get some high correlation? And we did at the national level, but you've always got to be really careful about that. And I think every talk today has probably acknowledged that issue in one way or another.
Yeah, that's a really good point. The one here, what would make using or tracking RTIs easier? Maybe I'll start with John and Sevi.
So I think this is all about data sharing. So certainly what would make using it easier is for there to be maybe a move in the way in which data is shared. Now, we're seeing that happen in the private sector. So Sevi's using private bank data, we're using private bank data. I mean, we know there's going to be administrative public sector data sets that are out there. And again, we have things like the Secure Research Service, as was mentioned earlier today, to try to share as much as possible in a trusted framework so that we can bring these new indicators to light, because to some extent, we don't know the full extent of what is available. And there are data sets that one hears about that might be held in bits of government or in bits of the private sector that we're really, really keen to access. So improved data sharing would be a real big innovation.
Sevi?
Yeah, the data share. So data sharing is complicated. So I give you an example. Now we are publishing our previous paper into somewhere, and it's a science journal, and they ask us, can you make your data public? The bank said, good Lord, no. So then we have to, so the compromise is to aggregate it in, in usable things that are acceptable for the banks. I think that regulation will be, eventually, regulation on these things will be critical, and that will move things ahead in many ways. But I guess the time span for this is long too.
Great. Final question. It's a great question, this. I'll start with Seri, then John. But what is the most unusual data that you have used?
Well, for us, it's we in principle, we not ourselves, because it has to be done by bank employees and so. But you can look at the record of whatever you did yesterday night when you went to buy something somewhere. You don't want to call and ask for what. I guess that's the more unusual kind of go. Everything is there, the usual and the unusual.
John?
So I think, in the broad scope of work, some of the most kind of interesting and unusual data that you get is the kind of free text data sources. So we've done some recent projects using chat data from within organizations. And I won't name the organizations, but you can imagine that within, if you take the history of our email accounts or the history of our Messenger or accounts or our Teams chats, there's some quite interesting stuff that turns up in natural language processing that isn't always what you'd expect to hear within the organization. But that doesn't apply to BIES, I'm sure.
Absolutely not. Look, thank you both. That was a really, really good. I'm sorry it was a bit truncated because there's so much there, but I would encourage everyone on the call to seek out the websites and the underlying papers. I think one of not necessarily unusual piece of data, but I remember at the very beginning of the pandemic, I spent a lot of time looking at the Google Trend searches, and the one that really struck me was searches for laid off in the early days of the pandemic, and you just saw it ratchet up until the minute the Chancellor announced furlough, and literally to the minute it just faded away, which shows, I think, both the power of essentially these measures to look at kind of in actual real time, to kind of get some sense of what people worry about and what stress looks like, but also to see actually a real-time policy response, which is really unusual. Look, thank you all. We're going to reassemble at 3:30 for the panel, and Jack the Chatter of NIESR will be chairing. Thank you all.
Thank you.